All right, so in this screencast, we do some more examples with the product rule and the quotient rule. If you already knew what the product rule and the quotient rule were, you jumped right to this video right off the bat. But if you did the other video that shows the theory behind the product and quotient rules, then you are ready for further practice, and I'll start with a quick example. So let's pretend that you have some functions, maybe f and g. That sounds fair. So we'll give some information in table form. So we'll have f of 4 and g of 4 and f prime of 4 and g prime of 4, and those are 10 and 5 and -2 and -1. So let's find the derivatives of, let's see, let's let h of x be f of x times g of x at x equals 4. And let's let, can't use h, j of x be f over g, and again, at x equals 4. So we want to demonstrate that we know the mechanics behind the product rule and the quotient rule. The product rule, it's a product. The product rule is so much fun. It's 1 prime 2 plus 2 prime 1, right? That's how this works. So h prime at 4, that's f prime g f g prime. Well, f prime of 4 is -2, g of 4 is 5, f of 4 is 10, g prime of 4 is -1, that's -10 minus 10, that's -20. On the quotient rule side, it's the bottom times the derivative of the top minus the top times the derivative of the bottom. For the rest, you won't be scared. It's all over the bottom square. This is calc, this is calc, this is calc. So when we find j prime of 4, that's g times f prime minus f times g prime over g squared. And that happens to be -10 minus, well, plus 10, right? -10 minus -10, that's 0. That's 0. The tangent line to f over g at x equals 4 is flat. Is flat. Okay. Example 2. Find h prime of x if h of x is the square root of x plus 1 times the square root of x minus 1. This is a product rule opportunity. Product rules are very straightforward. The product rule is so much fun. It's 1 prime 2 plus 2 prime 1. Right? It's the derivative of the first times the second times the derivative of the second. This is the derivative of the first. Well, what does that look like, right? It's the derivative of this thing. The derivative of 1 is 0. The derivative of x to the 1/2 is 1/2 x to the -1/2. And similarly, the derivative of this is 1/2 x to the -1/2. Well, how exactly does this work? X to the -1/2, that's a square root in a denominator. This is a square root in a denominator. Let's do a little bit of algebra. We can distribute, and we end up with 1/2 minus 1 over 2 root x plus 1/2 plus 1 over 2 root x. and these cancel, and you're left with 1. Now, is that surprising? Not at all, because the original function, if we were to expand the brackets, is x minus radical x plus radical x minus 1, right? The original function is x minus 1, whose derivative is definitely 1. Definitely 1. If I can do one more that brings everything together nicely, write an equation of the tangent line to y equals x over x plus 1 times x squared plus 1 at the point 1, 1/4. It's the equation of a tangent line. We know how to write the equation of a tangent line. The equation of a tangent line, it's y minus y1 equals x minus x1 multiplied by the slope. And that's where the formula comes from. So this is where the slope would go, but the slope is a derivative. We haven't found the derivative yet. So let's go find the derivative. This is a quotient. So we're going to use the quotient rule to find the derivative. It's the bottom times the derivative of the top minus the top times the derivative of the. For the rest, you won't be scared. It's all over the bottom square. This is calc, this is calc, this is calc. So what happens here? It's the derivative of the bottom. But the derivative of the bottom is a product. So in this space, the product rule is so much fun. It's 1 prime 2 plus 2 prime 1. And now we have the derivative. We have used the quotient rule on the quotient, and we have used the product rule where we needed the derivative of a product. At x equals 1, the slope of the tangent line is 1 plus 1, 1 squared plus 1, 1 minus 1 times what's in here? Well, this is 1 squared plus 1, that's 2. This is 2 times 2, that's 4. 2 plus 4 is 6. Over, this is 2, this is 2. They both get squared. And this turns out to be, so let's see, this turns out to be negative 2 over 16, which happens to reduce to negative 1 over 8, and that's the slope of the tangent line. We write the equation of a tangent line, y minus a y value, slope times x minus the corresponding x value. We have the y and x values there, so we just need a slope. Slopes come from derivatives. I hope this gets you going in terms of understanding product and quotient a little bit better so that you can find derivatives of products and quotients. We'll see you when we gather in class.